Hey guys, what's up? See, I'm here with your next topic, and this is again from the biomolecule. And this time, I'm talking about, the limitation of open structure of glucose. Why? Because we did initially that open structure of glucose, but then we came to the, hemiacetal cyclic structure of glucose. Now the question is why we needed that hemiacetal cyclic structure, because there are so many limitations associated with the open structure. So basically the topic, right now I'm taking is the limitation or failure of the open structure of the glucose. So I will talk about 4 of the failure, right? And what these are, let's take them one by one. So I have already drawn the glucose structure, which you've been, doing for almost like 5-6 days. So you remember everything about. The first one I remember, to make you go is that, glucose does not give 2,4-DNP test. It does not give 2,4-DNP test. Now the question is what this 2,4-DNP test is. The first thing I would say, that 2,4-DNP refers to a compound and it's called 2,4-dinitrophenylhydrazine. Now let me draw the structure and take you through the limitation part here. So this is this is your benzene here. That's your benzene. Now what you need to do, on any position you can draw that hydrogen part NH, and then you have NH2, right? NH2, and you have nitro right here and another nitro right here. So that's why this is called 2,4-DNP. So this is your 2,4-DNP, right? Now the question is, if this is something you can use. So what happens if this 2,4-DNP react with an aldehyde group, remember, which we believe that the glucose has here, on the very first carbon. So if this react with aldehyde or ketone, let me write this. If this react with aldehyde or ketone, it forms a red or orange or yellow solution. Now pay attention. What I'm trying to say is that when this 2,4-DNP is reacting with an aldehyde, it forms either a red or an orange or a yellow color solution. But what happens when this compound react with glucose, where we believe we have a aldehyde, no such products are formed. So there is no product coming out to be. So this is not forming here. And why this is not forming? Because that oxygen over here, remember that oxygen on the first carbon is used in making cyclic structure. You remember that? So because that oxygen in the aldehyde, on the aldehyde carbon is used in making the 6-membered ring of the glucose, and therefore there is literally no aldehyde available, and that's why glucose open structure do not exhibit the 2,4-DNP test, right? So this was the first one. I'll let you a bit about that. What happened here during the reaction is that aldehyde oxygen here, remember aldehyde oxygen here and 2 of the hydrogen from there, they together form water molecule. They form a water molecule, and this carbon bond itself to the nitrogen. So what that means, this carbon bond itself to the nitrogen, and that's why it forms a red, orange or yellow solution. But what is happening, there is no orange or red or yellow solution coming up because there is no aldehyde in a cyclic structure of the glucose, right? So open structure is not, able to give this 2,4-DNP test. That is the first, limitation coming out to be. Now let's talk about the second one. The second one is glucose does not give skiff based test. This is something new coming up for you. Skiff based test. Now let's pay attention and find out what this is. The first thing I would say, this skiff based is a huge compound, and I cannot draw it right here because this might spoil so much of time. So what I would say, that this particular compound, you need to understand that this is a colorless compound. This is a colorless solution. So when it react with an aldehyde, what happen? It results, pay attention, it result a red color PPT. Right? So this is the actual process, but because the oxygen in the aldehyde carbon of glucose is not free because it is used in making the six-membered ring. Therefore, this test is also not possible for glucose. So what I'm trying to say, that glucose cannot form this precipitate again, and therefore glucose is failing again to give the skiff test here. Right? So this is the second limitation coming out to be. What third is, just pay attention. The third one is that glucose, pay attention, again very important for your exam. Glucose does not give addition product with the NHSO3 with NHSO3. Let me tell you what this is. If you remember the nucleophilic addition reaction from the aldehyde, in case you do not, you need to go back and check out that reaction as well. In short, what I am trying to say here, that glucose, we feel like glucose had that aldehyde carbon with oxygen, but that oxygen is not free because it is used in making the ring. So what happened, because only the aldehyde can undergo this addition reaction with NHSO3, so there is no possibility that the open structure of the glucose will exhibit this, right? So we are not able to find out the addition product with the NHSO3. So this is the third demerit coming out to be. Now let's talk about the fourth one. This fourth one says, pentaacetate of glucose. Pay attention. Pentaacetate of glucose do not or does not react with NH2OH, does not react with NH2OH and form oxime. So this is going to be the last one. Just pay attention. What that means, that the pentaacetate of glucose cannot form oxime, which we feel like it might go and it might be able to form the product, because we feel like there is aldehyde oxygen. But because the oxygen is constantly being used in making of the ring, therefore it is also not able to form the oxime. So these are the four basic demerits or drawbacks of the open structure of the glucose, and I have to wind this right here. If in case you have problem, let me tell you very important thing. In case you have problem, what you can do, you can repeat it back. It's a very short lecture. You need another 5 to 10 minutes maybe, and then everything going to be very quick and very simple for you. So with this, I must wind this here. I will say thanks for watching and take care.